Yeah, live. There we go. Yeah, okay, we're live. So today, what we want to talk about is max-min problems in two variables. Okay, so we're going to do maximum, minimum, story problems, in two variables, which means you have to have two equations, okay? Anytime you get two variables, you can't solve an equation with two variables. You cannot. You cannot solve any equation if it has two variables, but if you have two equations, you can, because you can substitute, okay? Two variables in two equations, okay? When we did this before, remember we did the box, we cut the corners out of the box, right? The thing about the box is you're still left with an x and y, right? And you could graph that, okay? But here, what you're going to see in example 1 is different. You're going to see two things going on. With the box, it was just cut the box, right? With this, though, we're going to have to look at volume, and we're going to have to look at surface area. So we're going to need two equations, okay? So think about it. I'm going to take a box. Open the box with a square base. This could be constructed from sheet metal that has a surface area of 200. So we get this sheet metal, right, 200, and then we're going to make a box out of it. Now there's lots of ways to make that box, right? But you only have so much sheet metal, right? You want to make the biggest box because that's just the best way to do it, right? I mean, you're in business, manufacturing. So let's draw a picture first, okay? So first thing, I always like a picture because picture makes this so much easier for me. So I'm going to draw a 3D box here. And it has no top, okay? No top. Now, if it's a square base, we'd have W by W for width, okay? You guys okay with width? And then we have a height. W by W because it's a square base. Okay? So W by W, okay? Now, what I'm going to need is two different formulas, okay? So I'm going to need a formula for surface area and for volume. Now, the volume is easy, okay? Volume is just length times width times height, right? So it's W squared H, okay? Are we okay with that? Surface area is just all the sides, right? It's like, okay, so these are all rectangles. We have a base, which is W by W. So that's one rectangle, W squared, plus 1, 2, 3, 4 sides, right? Okay. And each side is a W by H. W by H. W by H, W by H. So each rectangle really is a W by H. So we've got 4 of those. So the surface area.
Would that actually be 2W squared?
No, because it's an open
There's no top. Great question. Oh, I'm glad you asked that. Good question because it has a open box. Really good job, Malachi. Normally I would put 2, correct? But it's an open box, okay? So now, what do we want to do? Well, I want to somehow express the volume as a function of its base width. So I'm going to go V of W. Because I want the volume as expressed as its width, okay? Which means this. All of these variables now have to be W. So V of W means all of these variables have to be W, okay? And then we have to do that because then we can graph it. You can't graph this with 3 variables. So what I'm going to do is come over here. And I want to solve then for H and substitute in, but I need more information. So I do know this, that the surface area is 200. So I'm going to put my 200 here. Okay. And if I can solve for H, I can plug it in for H here, and then all of this will be in terms of W, okay? So I'm going to solve for H over here, okay? Get my 2 equations, I can do that. So let's solve for H. Because if I solve for h, I'll have h equals blah, blah, blah w's. I'll put it in for h here, and everything will be in terms of w's, okay? All right, so I'm going to solve for w. So the first thing I'll do is go minus w squared. So 200 equals w squared plus 4wh. So I'll go minus w squared, right? I'll have a 200 minus w squared equals a 4wh. So I want to solve for h. My whole point of this is to solve for h. I'm going to divide then by 4w. And I might leave it in this form for right now, and I think you'll see why in a second. So I've got h equals 200 minus w squared over 4w, okay? All right, just leave it in that form for right now because I think you're going to see why. So now I want to take and put this in for h. When I do that, everything's in terms of w, right? So I have v of w now, the volume with respect to width. And all of my variables will be w's, they'll be width. So I've got my w squared times, not h, but what h is equal to. And h is equal to a 200 minus w squared over 4w, okay? How am I doing? Now that's technically correct, but if I am going to have to maximize, I'm going to have to graph this. I'm going to have to graph it. So I'm going to simplify this a little bit so that I can graph it. One of the things I see to simplify is I see a w with a w, so I'm going to rewrite this as a v of w equals a w times a 200 minus w squared divided by 4, okay? Divided by 4, okay? Okay, divided by 4. And now that's a form that I could put in my calculator. I could take a step further though. If I want to take a step further, I could go and make it a 1/4 of 200 is 50 equals a 50w minus a 1/4 w cubed. Okay, I'm going to make sure you see what I did, okay? Took a 1/4 of 200, but I also multiplied it by w, okay? Took a 1/4 of 250 and also multiplied by w, okay? I also made my w cubed, see my w cubed, but I've got 1/4 of that, okay? Now the reason I like this is because it makes it easier to graph it. So if I'm going to maximize it, I'm going to graph it, okay? So I'm looking for it, get my decimals out, okay? Now okay, let's use that decimals, huh? Okay, let's use that decimal, so I'm going to go to my decimals. Decimals, there we go. Oops, wrong one. I don't want to listen. There we go. Decimals. Of course, y and x, because that's what we just, so we go y equals 50x, w, same thing, right? Minus, I'm going to make it 0.25. It's easier 1/4. You guys okay with 0.25? Just easier. 0.25. It's easy for me to type it in. 0.25x to the third power, okay? Now, I don't see it because it's a big box, so I'm going to go looking for it. It's a big box. All right. Tap. So I get a point. I'm going to write my point down and think about what this point means, okay? So my point is at about 8.165. And I get a point at 272.166, okay? And I'll let you catch up. So I used my decimals, I typed it in. I want the maximum, right? Look for the maximum, so I tapped, found the maximum point, okay? How am I doing? Thumbs up? Okay, thumbs up, everybody? So what do we have? Well, in this equation, we really don't have x. This is w, right? So my width, I know my width, has to be 8.165 centimeters. And I don't have a y, but I have a v. So my volume is going to be my 272.166 volume, right, centimeters, cubed. Now let's build a box. So to build a box, we also have to know the height, right? Let's build a box. Well, find the height's easy because I have a little formula for the height, right? So if I take this answer and put it right over here, I'll get the height, right? Because I know the width, that'll give me the height, so let's build a box. So my height is going to be 200 minus 8.165 squared over 4 times my 8.165, my height. And I'm going to be careful. I'm going to make sure on my calculator, just because I make dumb mistakes, I'm going to use parentheses in my calculator, right? So I'll show you what I mean. Because I need the entire top to divide by the entire bottom, so I just use parentheses in my calculator. So I'm going to go, okay, what do I get? I get 200 minus 8.165 squared, parentheses, divided by parentheses, 4 times 8.165. Now I get the height to be about 4.08 or 4 rounded to 4.1, okay? So the height, about 4.1 for the height in terms of centimeters. So now we can build a box, right? Got it. Find the dimensions. The dimensions are 8.15, 8.15. So if I draw a picture of my final box, it's going to look like this for dimensions, right? I'm going to have 8.165, 8.165, and a 4.1, and the volume is going to equal 272.166 centimeters cubed. Okay, how's that?
Hold on.
I will wait for you. Definitely. Okay, so we can build a box, right? We can go in, we can build this box. It's the best box. Gives us the most volume, and uses the 200 centimeters, okay? Awesome. I love these problems. I know, I have a sick mind. I admit it. I do.
On the example too, I would just like to ask, why are you using two different measurements of distance? They're both miles and kilometers.
Oh, did I do that, Jack?
Yeah.
Okay, so I guess I only have one answer because I'm dumb. Which one do you want to use? Let's use,
Kilometers is more commonly used.
let's use kilometers. Oh my goodness, Jack.
I'm like, oh God, you have to do
No,
conversion.
no. That's just me being dumb. Thank you for catching that. Okay, I'll have to fix that. I'll fix that later after you guys are gone. Okay, so let's see how I can describe this, okay? Cameron, I want you to help me, okay?
Okay.
Okay.
What do you want me to do?
Stand up. Right there.
Okay.
And I'm going to stand. You get your radar, right? Okay, so a north-south trail intersects east-west road, okay? At 2 o'clock p.m., horse and rider will leave the intersection. I'll be the horse and rider.
Okay.
You head that way, okay?
In that way.
And then you're going to be on boat. Of course, you're the cool dude with boat.
Yeah, I'm the cool dude with boat.
I'm on the stinky horse and you're the cool boat. Probably have a boat full of girls. I'm sure you do, but that's cool.
Yep.
So, you're going a little bit faster than me, right? Because I think I'm going
I got 25 kilometers.
You're going
25.
16, right? So, watch this carefully. Just start, when I say go, start walking slowly this way, not
Okay.
like this way. Okay, ready?
Okay.
Okay, so watch it, ready, set, go. At what point in time are we the closest? You ready up there? Maybe, go back. Okay, we'll do it again. Okay, so just think about this. I mean, this is really, so, we'll do it again. Ready, set, go. Okay, at some point we're at the closest together. Because if we keep going, right, we'll eventually get further and further apart. So somewhere in that triangle, see a triangle? We're going to be the closest, okay? So let's figure out how that works. So first of all, what I saw was I saw a triangle, okay? Because the distance between us has an imaginary distance here, okay? So if I'm heading this way, you're heading that way, I'm going up, up, up. Let's just put a triangle right in here, okay? So, I see a right triangle, see a right triangle, and I'm looking at the distances between. How about Pythagoras theorem? You guys okay with Pythagoras theorem? Okay, so let's look at Pythagoras theorem. Which we know is a squared plus b squared equals c squared, okay? Good with that? So let's transform a squared plus b squared equals c squared into distance and time, right? Well, the writer is going 16 kilometers per hour, right? No, 12. 12, right? So we're going to call that a 12t. So as I'm on the horse moving away, my distance increases, right? My distance increases at this rate. After 1 hour, I'm 12 kilometers away, right? 2 hours, I'm 24 kilometers away. Half an hour, I'm 6, okay? Cameron, though, his distance to this spot is decreasing. It's actually decreasing because he started way out here at 25. So this was 25 kilometers on the boat, but as he comes in, his distance to this spot is decreasing, so it's minus 16t, okay? So his distance gets smaller and smaller. So it was 25, but his distance gets smaller and smaller, so we subtract the 16t, okay? Does that make a little bit of sense? And let's just call this d for distance, okay? Distance between, okay? Which is c. So here's my Pythagorean theorem, okay? I'm going to go d squared equals, well, or c squared. I'm going to rewrite it with d squared first, okay? So I'll use my Pythagorean theorem. D squared equals a squared plus b squared, okay? 12t squared plus 25 minus 16t squared. Make sure the squares are on the outside. Okay, this is great. I only have two variables. I don't have to do any substitute, but however, I can't graph this yet because I need to square root it, okay? I want to square root, so I'm going to go d is equal to the square root, right, of 12t squared plus 25 minus 16t squared, okay? And I'm going to call that d of t because it's the distance with respect to time. Now this makes sense, distance with respect to time, because as time goes on, right, Karen, as we're walking, time's moving, distance is changing, right? Distance with respect to time, right? If we're moving, distance is changing. Okay? The distance, d of t, time with respect, distance with respect to time, okay? Now, I can graph this, and then it's a little tricky to put in. I'm going to use my calculator to put it in. I don't know, you guys may or may not want to put it in decimals. See if you can, but I'm going to use my calculator. So I'm going to go y equals, clear that, square root, and I'm going to have to go parentheses 12x squared plus parentheses 25 minus 16x squared, okay? It's kind of hard to put in decimals, okay, but I can put it in my calculator. Now my window on my calculator, because I've got to have a window. So this window is crazy because, I mean, this is like 300 hours. I mean, we're going hours, right? So I'm going to go from probably 0 to maybe 1 hour, right? 1 hour on my horse. Scales by 1. And then my minimum, well, minimum distance is 0 to, well, the furthest it probably could be is 25, right? So I'll put that as 25. And I'll graph this, okay? So I'm looking for the minimum distance, right? Minimum. Okay, so I'm going to have to go a little further on my calculator because it looks like the minimum is starting to be right about here. So I'm going to change my window slightly. Let's go 2 hours and see what happens, okay? If I go 2 hours, I'm looking for a minimum, and there's my minimum, okay? So on the calculator, I don't know if you guys can put this in decimals. Anybody trying to put it in decimals?
I did, it's really weird.
Yeah, it's hard. So the nice thing about these calculators, so here's a feature on this calculator I really like. I go to second calc. It allows me to find a minimum. It needs a boundary. needs a boundary. Okay, so then I get this answer. Okay, so I get 0.999999. How about 1? You okay with 1? 0.999999. So we'll put a point at 1, comma 15. Okay, that's my point. Okay. So then, the 1 is my x, which represents time, and time is an hour. So t equals 1 hour. The 15 represents the y, but the y is distance. So then the distance is equal to 15 kilometers, right, Jack? Not miles, okay? So then, there's one last thing we have to say. What time is it? Well, what time do they start?
3?
Yeah, they start at 2. So the time is 3 o'clock p.m. Okay, that's what I have for today. It's pretty good, and I will work with you on the homework. That's one of the reasons I wanted to try and give you time to work on this, okay? Stop recording. And there's the homework. Stop recording. Stop. Stop.